Salam and hi all. Now we will discuss for topic 2.4 hypothesis testing. Note that hypothesis testing is the 6th step in the methodology of econometrics. Hypothesis testing consists of procedures for comparing conjectures that we might have about the regression parameters to the parameter estimates we have obtained from a sample of data. Given an economic and statistical model, hypotheses are formed about economic behavior. For a simple linear model, the hypothesis testing is concerned on beta 2. Since the focus of economic model is to study the relationship between variables x and y. In econometrics, test of hypothesis is divided by two parts that are test of significance and test of economic hypothesis. In the test of significance, we have one tail test and two tail tests. For one tail test, the specific test here is the right tail test. The right tail test is used when we want to check the positive linear relationship between variables, while the two-tail test is used to check the existence of linear relationship between variables. In the test of economic hypothesis, beta naught here is the hypothesized slope. The approach used for the test of significance is either t-test or p-value, depends on the instruction given by the question. While the approach for the test of economic hypothesis can be conducted using t-test only. That's all for now. The examples for hypothesis testing will be presented in the next video. Thank you. Let's look at example 2.41. By considering the data of example 2.2, the first case that we want to discuss here is to test whether there is a positive linear relationship between income and food expenditure by using t-test approach. In general, there are 5 basic steps in a hypothesis testing using traditional approach, and note that t-test is under traditional approach. The first step is to construct the hypothesis, and since in this case we want to test the positive linear relationship, so beta 2 here is greater than 0, and this is the claim that we need to test. And since the inequality used here is greater than no equals, so that's why this statement is under H1. Okay, so in step 1, our H0 now is beta 2 equals to 0. Okay, so complete step 1. So now we go to step 2. Step 2 is to get the statistical test value. The value of t-test here is obtained from the output of Microsoft Excel, which is the t-stat value for the weekly income, okay, can be obtained from the coefficient table of simple linear regression from Microsoft Excel. And from this table, we can get the t-test is equal to 4.8774 at 4 decimal places. So complete step 2. Okay, now we go to step 3. Step 3 is to establish the test criterion. That is to get the critical value and the rejection region. There are 3 factors to establish the test criterion. The first one is the distribution used for step 2. Okay, the distribution used here is T distribution. So we can plot T distribution here. Okay, and the second factor, that is inequality use in hash 1. The use is greater than, means that the rejection region is lies on the right tail of the T distribution. Means we can see that. Okay, this is right tail test, so no need to divide alpha by 2. And for this question, alpha is not given. And since alpha is not given, we need to use standard alpha, that is 0.05. So the T critical value now, that is T 0.05 with a degrees of freedom. So when we work with T distribution, we need to consider a degrees of freedom. And for this test, the degrees of freedom, that is n minus 2 for the regression test. So n minus 2, and for this example, okay, the number of data is 40. So 40 minus 2, so the degrees of freedom now is 38. And by using statistical table, okay, the value for T 0.05 with a degrees of freedom 38, this is equals to 1.6862. So now complete step 3, means that we can get the critical value and the rejection region. So now we go to step 4. In step 4, we want to make a decision on hash knot. So by comparing T test in step 2 and the T critical value in step 3, we can see that the value of T test here is greater than the value for critical value. So the decision here is reject hash knot. By using graphical representation, we can see that the value of T test here is lies on the rejection region. This means that the decision is support graphically. Okay. So now we go to step 5. In step 5, we want to draw a conclusion. So by looking at step 4, the decision is reject hash knot. So reject hash knot, step, in this case, this is we accept the claim. So the conclusion here is at alpha equal to 0.05, there is a significant positive relationship between household income and food expenditure. That's all for this example. So now we will go to example 2.42 in the next video. Discussing example 2.42. The case of hypothesis in this example is the same as example 2.41, where the difference between them is the approach used. In this example, we will use p-value approach. Basically, there are 4 steps in hypothesis testing using p-value approach. Step 1 is the same as explained in example 2.41, where the claim is under hash 1. Since the statement here is to test either there is a positive linear relationship or not between variables. In step 2, we need to get p-value. The p-value can be obtained from the p-value of B2. B2 is here. Okay, so get the p-value for B2. That will give us the value of 1.95 times 10 power of minus 5. Okay, this table is the coefficient table of simple linear regression from Excel output. So now we go to step 3. In step 3, the decision on H0 will be decided by using the rule of if p-value less than or equals to alpha, so we need to reject hash not. This is the basic rule for p-value approach. Therefore, in this example, by looking at the p-value here and we compare with alpha, and alpha in this case is 0.05, since the value of alpha is not given, so we need to use standard alpha. So in this case, p-value less than alpha equal to 0.05. So the decision here is reject hash not. So we go to step 4. Step 4 is to draw a conclusion. So step 4, if we look here, this is the same as step 5 in example 2.41, where we can see that since the decision here is reject hash not, so we accept the claim. So the conclusion here is at alpha 0.05, there is a significant positive linear relationship between household income and food expenditure. That's all for example 2.42. So now the next video we will look at example 2.43. Let's look at example 2.43. In this example, we will employ the data of example 2.2. The case here is suppose that the economic profitability of a new supermarket depends on household spending more than RM 5.50 out of additional RM 100 weekly income on food. The construction of the supermarket will not proceed unless there is strong evidence to this effect. Test either the construction of the new supermarket should proceed or not. So to test the statement given here, this is depends on the first sentence given here. Okay, from the first sentence we can see that beta 2, okay, because weekly income, the parameter for weekly income is beta 2. So beta 2 here, and the next keyword is, we can see the keyword here is more than. So more than RM 5.50. This is the claim that the construction will be proceed. Okay, so and since the including used in this claim is greater than, so the statement here is under H1. And then we construct H naught, where H naught here is beta 2 less than equals to 5.50. And this is the first step in hypothesis testing. So by looking at the test of hypothesis, we can see that the hypothesis that we constructed in example 2.43, that is under test of economic hypothesis, specifically under right there test. So by looking at the at the hypothesis here, we can see that beta naught here, okay, is the hypothesized slope. So looking back at the hypothesis constructed in this example, where beta, okay, this is the claim. So you can see that 5.5 here, actually this is the beta naught value. Okay, so now since we just construct the hypothesis, so complete step 1. So now we go to step 2. Okay, so note that to test the hypothesis under economic, only t-test approach can be conducted. So step 2, we need to get t-test value. So to get the t-test value, okay, we will use this formula. Okay, where t-test is B2 minus beta naught divided by standard error of B2. So the value of B2 and standard error of B2 can be obtained from the coefficient table of simple linear regression Excel output. Okay, so by using this value, okay, this is the value for B2 and the standard error for B2. Okay, and we substitute these values into the formula as well as the value for beta naught here. So we can get the value for t-test is 2.2498 at 4 decimal places. So complete step 2. So now we go to step 3. In step 3, we want to establish the test criterion by finding the critical value and the rejection region. And since the t-test is used in step 2, so that we need to compare with t critical value. Okay, by plotting the t distribution, okay, this is the t distribution, and by looking at the inequality used in H1 that is greater than, this shows us that the rejection region is lies on the right tail of the t distribution. So this is under right tail test. Or specifically one tail test. So in this case, no need to divide alpha by 2. And when we look at the question given, the value of alpha is not given. So we need to use standard alpha. The standard alpha is 0.05. So the critical value here is t 0.05 with a degrees of freedom 38. The value of 38 is come from number of data. In this case, the number of data is 40 minus 2. Okay. So that's why we get the degrees of freedom here is 38. And by using statistical table, okay, so the value is 1.6862. So since we can get the rejection region and the critical value, so complete step 3. In step 4, we want to make a decision on H0. So by comparing t-test and t-critical value, we can see that the value of t-test is greater than t-critical value. So in this case, the decision here is reject H0. Okay, because in this case, the test is under right tail test. Okay, so to support graphically this decision, we can see that the value of t-test here is lies on the rejection region. So this means that the decision is reject H0. Okay, so complete step 4. So now we go to step 5. Okay. To make a conclusion, so based on step 4, our decision is reject H0. Reject H0 means that in this case we accept the claim. So what we can conclude here that is at alpha 0.05, the new supermarket will be profitable. Hence, the construction of the new supermarket will proceed.